starting we're off once again. This is going to be 6.4 parametric equations. We're going to be kind of mixing the idea of the x and y, or the coordinate system or Cartesian plane, with sine and cosine. We're going to basically be solving for sine and cosine, and then plugging that in for x in things such as the x squared, or the Pythagorean identity. So let's get moving and see what we can find and figure out. So get you going right away. So like I said, we want to eliminate the parameter by setting cosine, or getting cosine by itself. So cosine t, kind of like the last couple sections, we want to get that by itself. So that's going to be equal to x over 30, which we got that by dividing 3 out of both sides. Now we want to get sine by itself, so we're going to divide 2 out of each side. So we have sine t, which is equal to y over 2. Now we see that we have sine and cosine by themselves. So now we're going to look at substituting what they're equal to in for the Pythagorean identity. So if we remember, the Pythagorean identity is cosine squared, I'll use theta just for fun, plus sine squared theta equals 1. So we're plugging in our new, with our y here, y over 2 for our sine, same thing with the x over 3 for our cosine. So we're going to have x over 3 squared plus y over 2 squared equals 1. Well, I'm going to take the square of both those terms, so I have x squared over 9 plus y squared over 4, which is equal to 1. Which, that step, it kind of gives you an idea of what we're working with here, or you can kind of see a little bit better. In this case, this is going to be the formula for what is called an ellipse. So when we have an ellipse like this, or we have an ellipse, we want to try and find where our center is, which is going to be affected by y and x. Since there's nothing happening to this x or this y, normally we either have like a -1 or a +1, or a -1 or a +1. Well, this time we have nothing. So our center point, or our main point, is going to stay at the origin. Now we want to look at our denominators, 9 and 4, which that's going to tell us, if we take the square root of that, or look up here, that number is going to be the distance from our origin that we need to go to mark our first main point that we're looking for, or points, I should say. So 3, we want to go a distance of 3, and since it's with the x, we want to stay on the x-axis. So 3. So we want to go both ways. It's a distance of 3 from both of them. It's kind of like a circle, but we're kind of going to push it down. So now we have the y with a 2 here, so we want to go up 2 and down 2. Okay, and then it's just a matter of connecting the points, kind of like a football is the best way to put it. So that's a little off on the bottom, but that's pretty decent drawing of an ellipse. So look for those keys. We're going to be able to see what I mean with the difference between a circle at the origin or if we move. So let's keep moving so we can get there. Okay, on the next page we have x equals 3 plus sine t and y equals cosine t minus 2. Once again, we want to get sine t by itself and cosine t by itself. So sine t, right away I know that's going to be equal to x minus 3. And then cosine t is equal to y plus 2. Okay, so right away, some of you may be thinking, how did you get 12? It's just that you're adding 2, getting cosine t by itself. So adding 2 there, and then subtracting 3 from up there. Okay, so we have them by themselves, and then once again, we just plug those into our Pythagorean identity for our sine and cosine, which I'm not going to write it out. If you want, you can rewind and go back and look at what the Pythagorean identity is in the last one. So we have x minus 3 squared, and then don't forget that plus is important. Y plus 2 squared equals 1. We just plugged in our sine, which would be y plus 1, or sorry, our cosine. So we plugged in our sine and our cosine, in these two spots. This is going to be your sine, and this is going to be your cosine. So right away, once I have that, notice how in the last question, I had kind of like a fraction here. Well, I have the same thing, but it's all over 1. So that means we're not moving anywhere from or I should say, we're not going a different distance out from the center other than just 1. So we're going to have a radius of 1 here, which that's kind of going to help us right there. So both denominators kind of tell us what our radius is going to be. So now we're going to go x minus 3. Well, if you remember back to algebra, x minus 3, we actually need to go to the right 3. Well, then we have y plus 2. Well, that's going to be down 2. So there's our new focus point, or our new origin. And now we want a distance of 1, distance of 1, distance of 1. And then we connect those. And just so we can see it a little better, I'm going to change colors up a bit. So we have a circle with a radius of 1. So that's pretty straightforward right there. And then we're going to go on to the next one, which almost put down the wrong thing. So the next question, let's get you moving. Sorry, I'm kind of slow here. Okay, now we want to get, once again, we don't have a sine, but we have a secant and a tangent. So let's get that by itself and see if we can do anything with that. So we have secant t is equal to, well, if I want to get that out of there, so secant is equal to x minus 3, and then we want to divide that 2 out after that 3 is taken out of there. So secant t is equal to x minus 3 divided by 2. And then tangent t, same format or situation for how we're solving, is equal to y minus 2 all over 4. If you have any questions about that, don't be afraid to ask me in your summary or in your questions at the end. So, okay, now, wait a minute, we're working with secant and tangent. We don't have, or that is not the Pythagorean identity. Well, if you look at your formula sheet, we do have an identity that will work. We have 1 plus tangent squared t equal to secant. So once again, we're just taking our secant, our new secant, and plugging it in, and our same tangent, and just plugging it in. So we have 1 plus, now looking at our tangent, we have y minus 2 over 4. That entire quantity must be squared, which is equal to x minus 3 over 2. That entire quantity squared. Okay, now we want to get this with this 1 on the other side. So I'm going to subtract this entire term here. So I want to subtract this entire term. I want to write nothing. So I want to subtract this entire term. So what we're going to do is we're just subtracting that. So we subtract the entire thing. The y minus 2 over 4 squared, and then y minus 2 over 4 squared. So we're going to be left with, I'm going to write these two terms on my left-hand side just so it's a little bit easier for me to look at. So I have x minus 3 over 2 squared minus y minus 2 over 4, sorry, quantity squared, which is equal to 1. So we move everything over here over, we want to move this over. Okay? So now we have two terms, and it's kind of looking like what we were doing before. I'm going to take the square root on both sides just so I can see what I'm getting out of there. So x minus 3 squared over 2, or sorry, 4. And then we have, that's minus y minus 2 16, which is equal to 1. Now this is a little bit different. Here we're going to have what is called a hyperbola. The idea with the center is the same, where we change it depending upon what happens to our x and happens to our y. So right away I'm going to go over and find my center. So we have x is minus 3, so I actually want to go to the right 3. And then y is minus 2, so I want to go up 2. So I'm going to go right there. There's my center. Once you have your center, that is your most important point. Now we want to go and look at our numbers below our original or our function or our functions or equations we had from before. Well, once it's squared, we know it's 4. Well, if we take the square root of that 4, we're back at 2. So, in the square root of 16, go back at 4. So that's going to be our total distance from the center out. So we're going to have we're going to make a little box here. Little box. So 4, 4. I put the 4 on, or I did one up and down 4 because that was attached to the y. I did that first. And then I went over 2 because that's on my x. So technically, like I should have said, you get a plus and minus 4 or a plus and minus 2. Okay, so now I'm going to make a box. Make a box. And everybody likes making boxes because they're nice and simple. Okay, Mr. Krause is great artistic ability. Now, we need to determine what I would call asymptotes. I think we've heard this before. The asymptotes are, the easiest way to do it is find your corners, find your center, connect them. And just keep going. Find your corners, find your center, and connect. Okay. So I have 2 more to do. This part is probably the most fun because you get to draw. I love being able to draw, especially in math. Well, now we need to know, do we have a parabola or a hyperbola that opens up like this or down like this? Or does it open from the sides? Well, the best way to do it now is to take our distance of 4 from our y and find it's called a hyperbola, which is right there. And right there, because that's the distance of 4. If we do the distance of 2, we're there and there, which doesn't get outside our box. We need to be outside the box. So we know we're going to have a hyperbola on this side and a hyperbola on this side. That hyperbola touches right to straight left or straight right of your center point. And the best way I tend to draw these is to start from the center. Okay, follow it up and don't touch that asymptote because asymptotes you will never get to it. Okay, so I'm going to just draw from the center out, from the center out. Okay, so that is how we draw a hyperbola. You can see my blue lines there are my hyperbola that I made. Okay, so we'll talk a little bit more about this through your homework in the next class. You all have a good night. I'll talk to you tomorrow. And I'll show you the homework real quick. Sorry about that. Don't forget to do the summary and questions. And there's your assignment that we'll be doing. Have a good night.